Now that we know what a derivative is, we can talk about velocity or instantaneous velocity. So the velocity of an object at time t is v of t. The limit as delta t goes to 0, s of t plus delta t minus s of t over delta t. So you're taking your change in time closer, you're taking the limit as that goes to 0, so you're really looking for instantaneous here. And so what this says is that really velocity is the derivative of position. So before we do the next problem, I do want to mention the formula for the position of a free falling object. So the formula would be s of t as negative 1/2 gt squared plus v0t plus s0, where, I know there's a whole bunch of symbols here, I'll explain. S0, this is your initial height of your object. V0, that's the initial velocity of the object. And finally, this g, it's either going to be 32 feet per second squared, or it'll be 9.8 meters per second squared, depending upon your measurements in your problem. Are you working in feet or are you working in meters? So let's look at an example now. At time t equals 0 seconds, a diver jumps from a platform diving board that is 32 feet above the water. The initial velocity of the diver is 16 feet per second. When does the diver hit the water? And then secondly, what is the diver's velocity at impact? So let's identify what our equation would be. So here I'm using feet. So G would be that 32. Let's write down our position formula. S of t, it's negative 1/2 gt squared plus v0t plus s0. So negative 1/2 times 32 t squared. What was our initial velocity of our diver? It was 16, so that's v naught. And our beginning position, our diver was 32 feet above the water, so s0 was 32. And this is our function now. So s of t would be negative 16t squared plus 16t plus 32. And I want to know, let's look back now that we have our function. What was I asked? when does the diver hit the water? So when means I'm looking for T. What's the height of the diver when it hits the water? Well, the height would be 0. So the position would be 0. So now I want to solve for T in this equation. You notice all of the coefficients are multiples of 16, so I'm going to pull out a negative 16. And now we need to factor what's left. This would be T, a 2 and a 1. So here I'm getting two solutions. This one tells me T would be negative 1, and this one tells me T would be 2. Now remember that T corresponds to time, so negative 1 does not make sense. So here's my answer. So I would say that the diver hits the water after T equals 2 seconds. Now that was only half of what I was asked to find. What was the second question I was asked? If we go back, what is the diver's velocity at impact? So I need velocity. So let's remind ourselves here. What was our position function? It was negative 16t squared plus 16t plus 32. To get velocity, we just need to take the derivative of this position function. So what would the derivative be? Use your power rule here. So it would be negative 32t plus 16. And I want to know what the velocity was at impact. So the diver made impact when t was 2. So you're going to plug in 2 here. And you get negative 48. And you need to put units on this. Negative 48 feet per second. And that was the velocity on impact.